Hello, nice to see you again. We've been talking about atoms, and so now we're going to get into a little bit of isotopes and ions. These are just variations on the types of atoms that we were talking about in class. So, as we're going through this, keep in mind protons, neutrons, electrons, because we're going to be talking about each and every one of those. So, just as a quick review, when we are looking at the periodic table and when we're looking at an element, we have this type of symbol that helps us kind of know some information about those atoms. So the top number, which can be designated Z, always tells you the number of protons. And remember that the number of protons comes straight off of the periodic table. It's its atomic number. The element symbol, pretty easy to remember. Just look at your big PT. And this down here is the element's average atomic mass. Now remember that this is when we're looking at the periodic table. But if we're talking just about one atom, then we can show it with a mass number. So instead of 6.9, this may be a 7 or an 8 or a 6. That means we're talking just about one atom. That means it's a full mass. All right, so when we start thinking about isotopes and ions, those variations on the atoms, all atoms of the same element are going to have the same number of protons. So in your head right now, think protons never change. Let's even make a chant out of it. Ready? Protons never change. 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 You got it? Is it burned into your head yet? Good. Okay, remember, elements of the same atom will always have the same number of protons. It's what gives them their identity. So if the proton number is the atomic number, this is a constant, that means things like sodium on the periodic table will always have 11 protons because its atomic number is 11. As soon as those protons change and you get 12 protons or 10 protons, then it is a different element. So protons never change. They give the atom its identity. So when we're looking at this atomic number, it's identifying the atom, but the other things can change in an atom. So if neutrons change, we call it isotopes. This is kind of like, almost like having twins. Okay? Twins look the same, but there's a few differences. That's what an isotope is. They have the same number of protons, but they have different number of neutrons. Therefore, they're just a little bit different. When electrons change, we call that an ion. That gives it a charge. So let's talk about those two things. We're going to start off in looking with isotopes. Now remember, an isotope is when the neutrons change. So if we have carbon 12, that means it has a mass of 12. This number down at the bottom is our number of protons, and we know that our protons plus our neutrons gives us our mass, because that's what's in the nucleus. That's the bulk of the atom. So that means our mass minus our protons have to equal our neutrons. So 12 minus 6, 6 neutrons. Well, if we look at another carbon atom, kind of like its twin over here, we have a mass number of 14 this time. Still carbon, so it still has 6 protons. So 14 minus 6 tells us that we have 8 neutrons. So here we have the same carbon atom, but different numbers of neutrons. So they're very similar, but they have a few differences. So these two atoms are isotopes. In order for something to be an isotope, it has to be the same element, just different numbers of neutrons. Let's look at another. This one is hydrogen. So hydrogen has 3 isotopes: protium, deuterium, and tritium. Deuterium gives you heavy water. It's radioactive. Tritium is also radioactive. So luckily, there aren't very many of those isotopes around in this world. This is the main one we see. But protium only has 1 proton, because remember, hydrogen on the periodic table is number 1. So that means it has 1 proton. All hydrogens will have 1 proton. So deuterium, still hydrogen, it's just an isotope, has that 1 proton. Tritium has that 1 proton. But deuterium has a mass of 2, and tritium has a mass of 3. Protium has a mass of 1. So this mass of 2 with 1 proton then gives us 1 neutron. 1 proton, 1 neutron. Tritium with a mass of 3, again 1 proton, has to have 2 neutrons in order to give it that mass of 3. So same element, same number of protons, but different number of neutrons. One more. Lithium. If we look at lithium, we have a mass number of 6. This atom has a mass number of 7, and this atom has a mass number of 8. So remember, all lithiums have 3 protons. Its atomic number is 3. So 6 minus 3 is going to give us 3 neutrons. 7 minus 3 is going to give us 4 neutrons. 8 minus 3 is going to give us 5 neutrons. Look at that basic math. 3 neutrons, 4 neutrons, 5 neutrons. But they all still have the same number of protons. 3 protons each. So same number of protons, different number of neutrons. All of these just a little bit different. All right, let's talk about some ions. So ions, remember, are when an atom has unequal number of protons and electrons. So the electrons have changed. Now keep in mind that a neutral atom always has an equal number of protons and electrons. So you can kind of think of, in an atom, they have all these protons, and there's an electron paired up with each of them. And when they pair up, they cancel each other out. They no longer have a charge. They kind of neutralize each other. That's why we call it a neutral atom. But when an atom loses or gains an electron, so say we gain another electron there, its charge changes. There's nothing there to cancel it out. So it gains a charge. That's what we're looking at ions. Keep in mind, protons never change. Protons never change. Protons never change. Protons never change. You cannot add or subtract protons. You can only add or subtract the electrons. So if we lose an electron, we gain a positive charge. If we gain an electron, we get a negative charge. Let's look a little deeper into that. So if we are losing an electron, so we have all these protons and they are paired up with all these electrons, and if we lose one, so this one gets kicked out, it's no longer there. Well, these cancel out and neutralize each other. Neutralized, neutralized, neutralized. But now this one is left over. So if we lose that electron, we have a positive charge. That positive isn't neutralized anymore. And elements, depending on where they're at, we'll talk about this a little later in class about why they do this, but they can lose 1, 2, 3, sometimes even 4 electrons. They just get kicked out. And so you can get a charge of up to 4+. Now when we're thinking about atoms losing electrons and they become positive, they're called cations. So one way I like to think about this is people that tend to have lots of cats. I've heard Miss Lindauer has lots of cats. So if you were to ask her what she thinks about them, she'd probably have a very positive view. People who like cats and have lots of cats are very positive about those animals. So ask Miss Lindauer about her cats and see if she's a positive person about that, because ions are the same way. Cations are positive. When we write those then, we would put the positive charge up at the top. Charges are always superscripts. They go super or up high above the element symbol. Now, if we go the opposite way, if they can gain electrons, that means we have a bunch of positives. They have their electrons hanging out with them. Neutralized, 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 neutralized. And if we gain another electron, there's nothing there to neutralize it. That means we have a negative charge that's left over. That means the whole atom is negatively charged. And just like cations, atoms can gain 1, 2, 3, even 4 electrons. So they can have a charge of up to 4 minus. A negatively charged ion is called an anion. One way I like to remember this one is it kind of looks like onion. And onions smell pretty negatively. So remember, cations are positive, anions are negative. So when we write this, just like the positive, we put that charge in the superscript up high, super, 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 superscript, and then we know what charge that has. So just a little chemistry humor to kind of finish us out. I'm hit, I've lost an electron. Are you sure? I'm positive. He. Another casualty in the war of the atoms. Do you get it? All right, so just a quick final review. When we have our atomic mass, we have our atomic mass, and if we subtract the neutrons, we would get the protons. If we have our atomic mass and we subtract our protons, we would get the neutrons. Because neutrons plus protons give us our mass. These are the fatties of the atoms. Electrons are just like air. So when we have different number of neutrons, but the same number of protons, we have an isotope. Remember, protons never change. Protons never change. Then, ions, therefore, have changing electrons. If the charge is 0, then our protons and electrons are the same. All of those protons and electrons have neutralized each other. Neutralized. And if the charge is positive, then the protons are greater than the electrons. That means we've lost an electron. And this neutralizes, doesn't neutralize. If the charge is negative, then the protons are less than the electrons. So we have more electrons than protons. Neutralized, neutralized, neutralized. Negative charge left over. Hope you are kind of comprehending this stuff. And again, if you have any questions, feel free to come in and see me or send me a message. And I will talk to you next class.